I'm going to be talking to Dr. George Shimizu, who's a professor in the Faculty of Science at the University of Calgary, about a really exciting development in the field of carbon capture and storage. His laboratory and team, in conjunction with a corporate partner, Savante, have developed a new nanotech membrane, a sponge-like nanotech material that captures carbon dioxide from flue gas on an industrial scale. And they're working on a project with a cement manufacturing plant in Vancouver. So I'm going to talk to them about that. Welcome to the interview, George.
Nice to be here. Thanks for having me on.
Now, this is really interesting technology because carbon capture and storage, I think, is acknowledged that over the next 20 or 30 years, it's going to play a major role in decarbonizing industries. And this is a world first. There's never been a material like this, never been piloted or demonstrated in a commercial application. Have I got that right?
For a larger scale carbon capture application. This particular class of solids that we work on, I think for the longest time, they've been regarded largely as more academic curiosity. So there are other commercial applications, but they are smaller niche applications. This is the first large scale industrial use, yes.
Now, and I understand that it was the pilot project was able to remove 95% of the CO2 emitted from this manufacturing plant. That sounds to me like a higher percentage than other carbon capture projects that I've seen, say, in the oil and gas industry.
Yeah, so 95% is of the demonstration stream. So it's being done on a 1 ton per day scale. So it isn't 95% of the emissions of the total cement plant. It's of the slipstream for this project. So in terms of how much CO2 can be captured, you can always capture more CO2. It just comes down to how big a facility are you planning to use, and what's the overall economics of it. But it really comes to, so in that sense, this is why 1 ton per day is still on an industrial scale quite a small scale. And so the idea is progressively de-risk at a smaller scale, and then tweak the process. I mean, the amine systems have had 20 years to advance incrementally, and this demonstration has just been running since January. So I think the data that's coming out of it is really promising, but it's still generation 1.
Sure, fair enough. Now, my understanding is that the CO2 is sequestered and then reused to improve the manufacture of the cement. Is it possible to use 100% of the CO2 that's captured?
Well, again, in this case, sure. I think in this process, it just depends on the ratio of the cement that's being manufactured and the quantity of it. But cement is a commodity that is used in large scale. But I think for a global CO2 capture perspective, there will always need to be some sequestration. Yeah.
Right. I guess that's what I was asking. If you can only use 50% of the CO2 that's captured from this cement plant in Vancouver, then what do you do with the rest of it? It's not like you have a nearby oil and gas reservoir that you can pump it back into. Any thoughts on what would happen if you can't reuse all of the CO2 in an application like this?
Yeah, so I think this is also, there are so many smaller emission sites that aren't near a sequestration site, and maybe they're presently not near a carbon pipeline. And so these are the factors that need to go into the decision making of where is it worth building CO2 pipelines. And the pipelines don't necessarily need to be immediately. They don't need to go across the country to sequestration. Maybe there's another facility that could utilize the CO2. Maybe there are facilities that could utilize more CO2 than they're actually emitting. So I think finding the synergy between all these opportunities is really key. And I think there's some opportunities for some good high-level policy decisions there.
Yeah, this is really interesting because Canada is considered a leader in CO2 capture and sequestration. I just recently did an interview with Wood Mackenzie, and they indicated that there's about 40 million tons a year captured, 7 of those in Canada. So we've got some big projects in Alberta like Quest. And so then that raises the question of can this technology be applied to the oil sands, which is 11% of Canada's national emissions. It's a big issue in a policy issue. What's your take on that?
Well, obviously, it's a huge emission opportunity. I think as far as our particular technology right now, ultimately, it could be applied to this. So the main challenges there are just every process gas stream is a different challenge. And so the focus right now has been, the initial demonstration is with cement, because the cement gas is actually a combination of natural gas combustion flue gas, which is around typically 3 to 5% carbon dioxide. But this is actually augmented with the carbon dioxide off gas from heating limestone, or the different carbonate minerals. And so when you combine that CO2 with the combustion flue gas, you get a gas stream that's about 15 to 20% and much easier to capture. And so in terms of a demonstration, this is the lower fruit, but it is also very important because the cement industry, most of the emissions I just described are not from the combustion. So even if you were making cement with renewable energy, you would still have CO2 emissions, significant CO2 emissions. So that would be like the cement and the steel industry. It's to decarbonize those, you have to have carbon capture. Going to renewable energy isn't enough. So in that sense, I'd say, de-risk with these technologies, and then we can look at the broader petroleum industry.
Yeah, it sounds like over in particular, this decade is going to be a really critical one for carbon capture technologies. And so if I understand you correctly, every application, whether it's a cement plant or the oil sands or some other energy related industry, there needs to be engineering to make it applicable to that particular application, that the composition of the flue gas. Is that right?
That is absolutely critical. And I think I think there's less and less of a sense that people are looking for a magic bullet that will do everything, and that simply isn't going to happen, because the process conditions are so different. Not just gas compositions, but if something comes out at a high pressure, high temperature, is it worth depressurizing it and cooling it to accommodate a different capture system? If you can really keep the energy in a system and have minimal energy flux to do to use the energy in a system, just redirect it to do the capture and the regeneration. That's ideal.
So, final question, George. Given the work that's been done in particular in Alberta around carbon capture and storage already, we have a decade or more of experience at this. Given the work that's being done, like researchers like yourself, is there an opportunity here to create a Canadian cluster of technology and expertise that Canada can then export to other countries? This is a global problem. And CCS is being considered as a solution at a global level. So can we become a leader in this and export technology and expertise?
Oh, absolutely. I think that's already happening. And I think the way to do that is, I think we're in a good position with leadership. And the other thing is, we can have demonstrations because we also have something to do with the carbon dioxide, right? We're fortunate to have geology that really enables large-scale sequestration. So I think a lot of technologies can be, again, be de-risked in Canada, can be developed and de-risked in Canada. Absolutely. I think other countries with much denser populations, I think the sustainability is maybe more on people's minds on a day-to-day basis. At least that's my impression. I see people, people walk more. They seem to be a little more conscious of their own personal footprint. They won't idle big vehicles as they're sitting waiting for people. So, but yeah, I think there's good opportunities for learnings in both directions in a lot of ways.
Terrific. George, thank you very much for this. Really appreciate your insight and good luck with your technology.
Thank you very much.